Welcome. So glad you're here. We're going to talk today about confidential containers. I'm Whitney Lee. I'm a developer advocate, and I'm here with Tobin. Tobin, will you introduce yourself, please?
Sure. My name is Tobin, and I work for IBM Research. I work at the research center just outside of New York City, working on security, mainly secure virtualization for the cloud and confidential computing, which is what brought me to this confidential containers project.
So Tobin and I just spent almost 2 hours talking with each other about confidential containers. Tobin taught me everything there is to know. Just kidding. Just as much as could fit on this board, which is a fraction of what there is to know. But in the meanwhile, here's the recap for you. So can you go into what confidential computing is?
Confidential computing is a hardware technology, but it's also sort of its own paradigm or its own trust model, its own way to build your software. It is hardware technology that protects data while it is in use. Before confidential containers, this was out there, but it was hard to use. It was non-standardized, looks different on different hardware providers. So it was a lot of work to be able to use confidential computing for anything meaningful, especially if you had a complex cloud-native workload.
So then what confidential containers does is that it solves that problem of integrating confidential computing generally into Kubernetes or your cloud environment specifically.
We want to make it as simple as possible for real cloud-native people to use confidential computing. So we are doing a lot of heavy lifting to figure out how do you standardize things? How do you pull things together? What are the right ways to actually set up your workloads, take care of all these things? Because there's some very complicated questions in there. Take care of those things so that when you come to confidential containers, you can install an operator, set up some runtime classes, and get going pretty quickly.
Exactly. I've been doing a lot of learning in the security space area, and I've learned a lot about securing data when it is at rest, like in your secrets management, for example. And I've been reading a lot about how to secure data when it moves through a network with MTLS, for example. But what we're talking about here is securing your data while it is actually in system memory, while it's being used by the application. From what I understand from learning from you, that isn't being tackled anywhere else in the ecosystem right now.
I mean, the point of having data is usually to do something with it, but when you actually execute commands on a CPU on your data, it's usually exposed to the person who owns that CPU. If you're using a traditional container, then the host kernel is probably not under your control, and it can see and influence control flow. Even if you're using a VM, it's a much stronger isolation boundary than a container, but still the owner of that machine has access to something like guest memory. They can at any time just stop the VM from executing, dump all the guest memory, and see what's going on. So confidential computing is something that will completely prevent those kind of attacks and enable a really sort of profound shift in the way that we think about the relationship between a host and a guest and a cloud provider and a client.
Not only are we not trusting whoever owns the machine, the physical machine, but part of this model is to not trust the Kubernetes control plane for confidential containers. And that's pretty fascinating. But before we jump into this, I think maybe one more bit of context that's important. Well, you taught me that confidential computing needs its own specific hardware. It can't just run anywhere. Will you talk more about that?
This is a hardware technology. These things, I mean, what I just described is not trusting the host. Good luck doing that without modifying the hardware itself. This is a huge undertaking that's been a long time in the making. There's almost every major hardware provider has some sort of confidential offering. The big ones are on Intel, TDX or SGX. On AMD, there's something called S&P or SEV S&P. And there's a CCA on ARM or secure execution on S390. Other platforms have similar ideas, but confidential computing is really becoming much more common in hardware. And that's what all of this work is based on. Really, those changes in hardware set in motion a huge shift, traveling up the stack and just now reaching Kubernetes.
That's fascinating. I'm pretty new in this space. And one thing that Tobin had to teach me to really understand, when we talk about a secure place, we might mean, we could say it as an enclave, as a guest, as a realm, as a trusted execution environment. With confidential containers specifically, we're adding that confidential computing at the pod level, but we're talking a lot about a VM in terms of the VM is the thing that's the trusted place. So there are two big parts of confidential computing or confidential containers. One is attestation and one is isolation. So will you go into that concept?
We sort of already alluded to this idea that you're protecting your workload from the host and from everybody else, really, everyone that's not you. So this implies very strong isolation boundaries. This is usually done with like encryption of guest memory. We won't get into all the details. There's a lot of different mechanics that enforce this, but a big part of it is about building really big walls around your VM. And like you said, it is done at the VM level, but not always. So part of it is isolation. This is sort of like if you had a castle, this would be the walls. But there's something else that's extremely important, which is attestation, which is knowing what's actually running inside of it. The walls aren't really very useful if you don't know what's actually in them. So confidential computing architectures always have a component that allows you to in some way measure or attest what's actually running. And that whole process is represented in the confidential containers architecture as well, and is an integral part of how you deploy a confidential workload.
One thing you taught me during our longer conversation is that when you say like you're attesting a safe place and you're knowing what's in that safe place, my mind went to like, oh, you're knowing like about the container image that's running there, or you're knowing about the workloads that are running there. But you actually mean like you're attesting the VM itself, right?
So these measurement things usually cover like the initial memory of the guest, the initial CPU state of the guest. So it's really a picture of entirely what that guest looks like. There is some lifting to do to understand what that should look like, to understand what the expected measurement is. And that's also something that confidential containers will help you with in actually verifying what attestation and what measurement you get.
So we talked about cloud computing generally. We talked about confidential containers specifically. Very easy to use, but do require special hardware. And then there's a lot of very complex stuff going on under the hood. I feel like maybe it's time to dig in more on how it works. First, I'm going to lead with the 3 takeaways, and then we'll also end with these 3 takeaways. So the first thing that's important is this VM, which is the safe space, which is, you like to call it a guest, but this is the attested area. This VM it may hold a lot of stuff, but it's going to hold only one of your actual application pods, only one workload pod. This VM itself at a 1-to-1 with the workload pod. And then to help keep this VM confidential and safe, any images pulled need to happen inside the VM as opposed to happening on the host or by the Kubernetes control plane. So that's an important problem to solve. And then the other thing is getting the secrets, having a safe way to get secrets that maybe decrypt your image or maybe just secrets that your workload needs. How are we going to get those secrets without trusting the host or the Kubernetes layer? So those are the three big things that are happening. And let's talk about how they happen now.
Let's say you want to run a pod. Talking about pods here. You would run kubectl apply-f your pod.yaml, and that would get in contact with the control plane. And we'll skip ahead to the part where you show up on the kubelet on your worker node. This is untrusted. It's on the host. The kubelet is going to the CRI interface and say, I'm trying to pull this container. I'm trying to set up this sandbox. And this is the point where we would intercede for image pulling, at least. We have a snapshotter that will intercept this request in container D to make a new container, and it will use a component inside of the guest to actually pull that. We'll come back to this in a second, but the rest of these requests, besides pulling the container, will continue on to something called the Kata shim. And the Kata shim basically is an OCI interface, so that will live in place of something like runc, where normally you would just start up a container with runc locally, set up the C groups or whatever else. Here, you will start a VM. So the Kata shim knows that the first order of business, when it's supposed to do stuff, is to start up the VM where everything's going to live. That VM is going to contain something called the Kata agent. And there's an API between the Kata shim and the Kata agent. And the Kata shim, for the most part, after it starts the VM, it just passes the requests it gets to the Kata agent. And then the Kata agent will do these. So I mentioned how we have pulled the image inside the guest already. That's where the component called image.rs. So that by the time that the Kata shim asks the Kata agent, hey, can you start up this container? It will have already been pulled inside the guest. If pulling this container image involved a secret, so if we had an encrypted or a signed container image, which most of our workloads will have, then we need to do one extra step, which is that we need to trigger an attestation, and we need to trigger our important pathway for getting secrets. There's one more component here, which is the CDH and the attestation agent. These two work together, and they provide secrets to the guest in conjunction with some sort of attestation. And they do this with the help of a trusted third party, which we call the KBS. And this runs someplace that you trust. Could be in your house, on your local computer, could be some third party that you trust for various reasons. But the CDH and the AA will get the attestation, the measurement from inside the guest. They'll give it to the KBS. The KBS will verify that it is correct. If it is, it'll give you back the secrets. These secrets could actually be anything. They could be credentials needed from inside the workload. They could be a key to unwrap wrapped Kubernetes secrets, or they could be something to decrypt your encrypted image, which is where we started this whole thing. So if it's an encrypted image, do this whole secrets thing. The image will be decrypted by image.rs. The Kata agent will start it. Your pod's running, and that's it.
Easy peasy. There are a couple of things I wanted to add. Kata is a separate project, and its whole thing, regardless of whether it's being used in the confidential containers context, is that it makes VMs for you in Kubernetes.
Kata is an existing project that encapsulates pods inside of VMs, and they can be non-confidential. So you could use it today without any of this if you just wanted VM-based isolation for your pods.
The other thing I thought was really interesting is like the CDH, the confidential data hub, and the attestation agents what they're doing is they're working together to attest the environment, but they're actually assessing then the environment that they're actually running in. And so that seems complex, but I think it's really just worth mentioning because it's cool and interesting that they're not getting any outside information. They're doing what they can from where they are and creating a picture of what this looks like and then presenting that to the key broker service.
Well, one thing to note is that if you don't have this hardware sitting around, we also have integrations to do this in the cloud. This cloud integrations, typically the way they work is that rather than starting this pod VM locally, you can call up a cloud service provider and ask them to start a confidential VM for you. So if you don't have fancy Epic server or Sapphire Rapids machine, you won't be left out. There's ways to do this in the cloud. Other than that, I just say that we really welcome a lot of contributions. We have a great Slack channel in the CNCF Slack, confidential-containers, and a whole bunch of other subsidiary Slack channels. And we have a weekly community meeting where we talk about the project and about confidential computing and security more generally. It's probably the single largest concentration of confidential computing knowledge in the world. So it's a good place to just stop by if you're interested in it. And we also have presentations about all kinds of topics there. So if you happen to have a security project that might be related, let us know.
One thing I want to reiterate from this whole thing, especially after going through the rather complicated process of how it works, is as a user, just want to say again how easy it is to use. You just have to install Kubernetes operator. You do need the right hardware, but you can't get that through your cloud provider, as Tobin just said. And then you add a runtime class to your workload, and then all this stuff happens for you automatically, as they say, behind the scenes. Thank you so much, Tobin, for sharing your time and your expertise with us. And thanks everyone for watching. Goodbye.